Isn't it like the middle point? Like the one directly in the middle?
Yes, it is actually in the middle. And I don't know whether I actually said it like that. What happens at that middle point? Yes. So, Maddie, would you be willing to say that out loud?
It becomes the turning point.
Yes, it is in the middle, and that's an amazing description. I love that. It is in the middle of your graph, and it is where the graph turns around. Okay, so the vertex is the middle of the graph, and it's the turning point. And the middle is actually very significant. I don't know who said that, but that was a great description of it. I didn't see who was talking then. So the vertex, so we're going to make a note over here that the vertex is the turning point. And it is in the middle of the graph. Okay, so we talk about the fact that if we can find the vertex of a parabola, we can do some really amazing things with it. In the section on graphing, we could use that to help us move it around. Okay, so having that turning point, we knew where to move it to. And if you recall this inside movement, if I had x minus 3, for example, it would have moved 3 units to the right, plus or minus whatever the last number is, and that then becomes my vertex. And so we're going to see that play out here in just a minute. But the reason the fact that it's the middle of the graph is significant is because we have this thing called an axis of symmetry. And an axis of symmetry is a vertical line, right? So thus we have to write it as an equation. X is equal to a number, and that number is always the x part of my vertex. So please make sure if it says what is the axis of symmetry and you just put like 3, it's going to tell you you're wrong, okay? So the reason that it's wrong is because that it has to be that equation. It has to be x equals to a number, okay? So it is a vertical line, and we always write it as an equation. Now, the other thing that kind of connects back to what we did with graphing is if I have a negative x squared, that's going to take my parabola and it's going to turn it upside down. Remember, it flipped it across the x-axis. If I have a positive x squared, we know that the graph opens up. And so when we talk about relative maximums, relative minimums, which was also had to do with graphs, if the graph opens up, then its vertex, its turning point, its middle point is on the bottom, and therefore we say it has a relative minimum. And actually, this is an absolute minimum, but we're not going to distinguish between the two in this class, okay? So if the graph has a negative in front of the x squared, then it's going to open down, and so my vertex, my turning point, is that relative maximum. So this a is the number in front of the parentheses or in front of the x squared. Everything I just got through saying about the standard form also applies to a quadratic function if it's in general form. And general form just means it's a little bit harder to find the vertex, but I'm going to give you a formula for that. So everything else is exactly the same. If it's positive x squared, it opens up and has a minimum. If it's negative x squared, it opens down and has a maximum. The only difference is how we actually find the vertex. You can do something. We talked about solving quadratic equations the other day by completing the square. You can complete the square on a function. It's a little bit funky to do, so I usually don't teach it. But if you have a really good algebra class in high school, maybe like an algebra 3 class in high school, you may have learned how to do that, and that's perfectly fine. I tend to teach the formula for finding the vertex if it's in general form. And what happens is that the h part of the vertex is still hk. That h part of the vertex comes from negative b, coefficient of x, over 2 times a. I don't care about the constant out here. And then to find the y part, we'll plug that in, and I'm going to show you still how to do that. So the vertex is still very important. The axis of symmetry is still x is equal to the h part of the vertex, and then that vertex is either a maximum or a minimum. We're going to go through lots of parts of this as we go through these problems, but I just really love this summary page so that you can see what's happening with all of this, and you just have everything in one place. All right. So let's look at just another kind of visual to remind you and help you see what's happening here. Again, I am a very visual person, and so I tend to force those visual aids on my students. I'm so sorry if you are not, but I just think it helps you to see that math. So again, and it doesn't matter what form my equation is in, so if I have a quadratic function, my vertex is this point hk, if the or the coefficient of x squared is positive, my graph is going to do something like this. It's going to open up, my vertex is going to be that minimum. If it opens down, my vertex is going to be that maximum, okay? You can see this axis of symmetry, and that's what this is here. This is the axis of symmetry. One of the things we talked about with functions the other day was even and odd functions. And even functions are symmetric about the y-axis. Well, quadratic functions are always symmetric about their axis of symmetry. So I could fold my quadratic function across that line, and then everything would line up. And therefore, it's letting me know that it is symmetric about that equation. Now, that equation is not part of my graph, but it is significant in that I know around that vertex, I'm going to have that symmetrical shape for my parabola, okay? The other big thing from this is it's a nice visual, and you can either look at the visual or you can actually just memorize this. My domain for these is always all real numbers because they're polynomial functions. The range we can either get by graphing, and remember the range is the y values. So if the graph opens up, then my range has a minimum, it has a starting point, and it goes from that y value to infinity. If my function opens down, then my graph has a maximum point. So therefore, my range has a stopping point. It has a largest value, and it's going to go from negative infinity to that value. Okay. So hopefully, we're going to see how this all goes together. But this is kind of a nice, again, it's a visual for your domain and range, and we'll put it all together. Okay. Questions about this? And we can come back to this too. Okay, perfect. So for these problems, we're not going to do anything except you're going to tell me whether or not this function opens up or down, okay? So it is a quadratic because its power of x is x squared, okay? We don't want to look at the graph. We just simply want to determine, does it open up or down? And I need to know what you're looking at. So I need everybody to tell me, do you think this function opens up or opens down? Just send it to me in a private chat. Opens up, opens down, number one. I'm only going to answer you if you're incorrect. So far, I've got 2 correct answers. Yep, yep, yep. Yep, yep. Don't answer about number 2, just number 1. Yep, yep, yep. Yep, yep, yep. Y'all are great. Y'all are wonderful. Anybody else want to chime in on here? Excellent. Okay. I'm caught in stuff. I got to answer one person. Okay. Think I've got replies from almost everybody. Okay. So I'm going to pick on somebody, and let's see who I'm going to pick on. Blaine, I haven't heard from you recently. either out loud or you can chat to everybody. Tell me what you looked at to determine that it indeed does open down.
I looked at the negative sign
The negative sign where?
in the 2x squared.
Yep. So this little guy right here, you look at the x squared, wherever x squared happens to be, okay, because this is my value of a. So a is equal to -2, which means that it's less than 0, which means that the graph is going to open down. Excellent. Okay. So now, what is the value of a for problem number 2? Somebody look at problem number 2, and you can shout it out to everybody. You can verbally shout it out, or you can type it in, shout it out. What is the value of a? Be careful.
+5.
Yes, excellent. I'm getting lots of answers. So
He stole
+5.
my thunder.
What now?
He stole my thunder.
Well, you'll have to jump in there and be quicker next time. So +5 is this x squared. So that means it's positive, and that means this graph is going to open up, right? That's all we're looking at right now, okay? Does it open up? Does it open down? Okay. So now with that in mind, I'm going to ask you to take this a step further. Since number 1 opens down, if I could find the vertex is going to be a maximum or a minimum since it opens down. Think about what that open down looks like. Yep. It is going to be a maximum. And you know, and I love this in class because a lot of times I'll watch students and they're like, opens down, okay, here it goes on the top, opens up, here it goes on the bottom. I mean, it is very, I mean, you'll see me do this. I mean, I do this all the time. It opens up, I have to stop and think. I have, you know, opens up, I have a minimum, opens down, I have a maximum, okay? So that very visual kind of thing. I usually tell my students in class, you have this portable parabola that you can carry around with you everywhere you go. So here's your parabola, and think about what it looks like, okay? So since number 2 is going to open up, then my vertex is going to be a minimum, okay? Excellent, very good, very good. Okay, so let's move along with this. So this one's got lots of parts to it. We're gonna put all of this fabulous stuff together. It doesn't matter to me whether you know that this is standard or general form. I don't care if you know the name of it. I care if you can get information out of it, okay? So I'm going to ask you to think about what we did in section 3.4. I was trying to remember which section it was, okay? The transformation of functions, okay? So x minus 2, remember this is to my x value. This is a great review for your test, all right? This is my change in my x value. This causes it to move 2 units to the left or right. Review for your test. Ooh. Nice review for the test. I only got one correct answer. The -2 causes it to move to the right. Okay, remember it's the opposite when it's inside. Okay, the other way you can do this is think about x minus 2 equals to 0, so x would be equal to +2. All right, okay, but we're not going to miss that on the test now. All right, so let's see what happens with this -4. Where does that cause it to move? And I'm going to tell you it's an up or down. Yes, it is going to move down. I know, it is crazy. So, but, and I'll tell you why it's happening. And that really might help you out. So that literally putting that x minus 2 equal to 0, so that inside thing equal to 0, this is telling me where the 0 is for my function. And so my 0 that not up and down, that where it's not going to be, it's going to be on that x-axis. That 0 for the function is going to start at x is equal to 2, okay? Now, I'm going to move it up or down based on the second part of that, but that's what that initial part comes from, okay? So that might help a little bit. I know it feels kind of weird because it is the opposite, but it's the same thing in a circle. Okay, so because it moves right 2 and down 4, you're like, why are we doing this? Because, guys, that's what the vertex is. The vertex is 2, -4, because it moved right 2 and down 4. And that's your vertex. If you go back and look at that formula, you pull the number that was subtracted from x and then the number here, okay? So I told you that in general, it's a times x minus h squared plus k. Well, my k value is -4, and 2 was subtracted from x. And so there's my vertex. Okay. Second part of this, does this graph open up or down? Does this graph open up or open down? It does. It opens up, okay? And it opens up because A has a value of 1. It's understood right here, okay? It's positive, and therefore it opens up. So it's not going to open down, okay? So my graph is going to open up, has this vertex. Life is being fabulous right now. The equation of the axis of symmetry. I'm going to see if anybody was paying attention to me a while ago. I want you to type in the axis of symmetry. You can type it into everybody. You can just chat it to me. The axis of symmetry. Okay, and so several of you are telling me it has to do with H, but you got to figure out what H is. If you're just giving me a number, I'm going to say, wrong. I feel like a game show. There you go. Two correct answers so far. Aha, nicer. Okay. All right, so my equation of the axis of symmetry is x equals 2 in this case. 2 because it's the h part of my vertex, okay? But it has to be, and guys, this is one of those that if it's a type in answer on your test and you put 2 and it says what is the equation of the axis of symmetry, I am not going to give you credit for it because the answer is the equation x is equal to. Okay, so be careful. All right, finding the x-intercepts or the zeros of this function. The x-intercepts or the zeros of the function are the values of x where the function is equal to 0. Okay, so to find these, then we're going to take my entire function, x minus 2 squared minus 4, and we're going to set it equal to 0. Excuse me. And we're going to solve for x. And once again, we're putting so many things together. So I'm going to add 4 to both sides. I'm going to take the square root of both sides, and I get x minus 2 is equal to positive or negative 2. And so these two equations, x minus 2 is equal to 2, and x minus 2 equals negative 2, are my two equations I'm going to solve. If I add 2 to both sides, I get x is equal to 4. If I add 2 to both sides here, I get x is equal to 0. So one of my zeros is going to be the 0.40, and one is going to be the 0.00. The actual zeros for the function are x is equal to 4 and x is equal to 0, okay? We're going to come back and revisit this. The y-intercept, remember, because it's a function, there's only one y-intercept. The y-intercept is also known as the point where x is equal to 0. And so I have 0 minus 2 squared minus 4. This is going to give me 4 minus 4, and I'm going to get 0. Somebody in this crowd probably looked at this point and said, hey, if that's the x-intercept, is that not the y-intercept also? And the answer is yes, okay? If the origin, hear me carefully, if the origin is either your x-intercept or your y-intercept when you're looking for it, it is also the other one, okay? So if you get the origin as one of your x-intercepts, that is also your y-intercept because it's where the x value is 0, okay? All right, so the next part of this says sketch the graph using the vertex and the intercepts. So we're going to sketch the graph. We're going to plot the the vertex here. Here is my vertex. Here is one x-intercept. Here is both my x and my y-intercept. Okay. Oh, okay. So for when I solved my equation for 0, I'm backtracking as to why we got 0, 0 here, okay? So when I let my function be equal to 0, because that's how I get my x-intercepts, all right? When I solved this and I took the square root of both sides, I got both. So let me come over here real quick. So if I have x minus 2, because typically if one person's got a question, multiple persons have a same question, this gives me plus or minus the square root of 4. And that x minus 2 is then equal to positive or negative 2, because that's what the square root of 4 is. And I have to solve each of these little equations in order to get both of my values of x. Remember that x squared tells me I'm probably going to have 2 values of x, okay? So when x was 0, or when y was 0, and that's what this is, then I found that x was 0 also. So my zeros or my x-intercepts are always going to be written as ordered pairs, where the second component is going to be 0, okay? Because that's what we let y be equal to 0.
Second component is always going to be 0.
For my x-intercepts, yes.
Okay. All right. Thank you.
And for the y-intercepts, the x is always going to be 0.
Okay.
Okay.
All right. That makes sense. Thank you.
Yep. Nope, that's what y'all got to ask. So, okay. So now I'm going to sketch the graph, and we're going to see if it kind of lines up here. I know my graph is kind of funky. I just have a hard time with that right side of my functions. Okay. So here is my graph. Okay. It works with, it opens up where everything lines up. It should be kind of symmetrical about this. I'm going to draw this little line in here. I'm going to try to draw this little line in here so that you can see. There is my axis of symmetry. And I know it's not great, but here is my, it's not part of my graph, but just so that you see, here is my axis of symmetry, is my vertical line, and my graph should be the same distance on both sides. So I can't draw it, it's close enough. All right, the last part of this question says, okay, we want to state the domain and range, and we want to use interval notation. Well, the domain for this function should be like, it should just fall out of your hands, okay? It is negative infinity to positive infinity. And the reason I'm telling you that is this is a polynomial function. Quadratics are polynomials. Domain for polynomials is always negative infinity to positive infinity, always, okay? Now, for the range, you can either look at the graph, or you can go back and think about what we talked about a while ago. It has a minimum because it opens up. I didn't ask you to identify that, but it does have a minimum. So in other words, on my range, it has a starting point that has a smallest value. That smallest value is this y value right here from the vertex. So the vertex, the y part of the vertex always is somehow involved in your range, always, okay? And there's my range. Questions on any other parts of this? Or the same parts we've already talked about? Okay. Let's look at the next one. I told you we're putting all of these fabulous things together. Okay, so I'm going to actually give you just a couple of minutes to see if you can answer these, and then we'll come back and talk about them. But I think it's super helpful. I mean, I can walk through and tell you absolutely every answer, but I think it's really helpful to you, at least these first three. So we'll do the x-intercepts together, but answer these first three real quick, okay? And you don't have to answer them to me. I just want you to put them on your paper, and then we'll talk about what you got here. And if you're stuck and you don't know where to begin, send me a private message and say, Or you can say, I'm stuck, I don't know where to begin. And I get you started. Okay. That is, we are good. We are good. Okay. So I'm going to jump start and get you started here. A couple of y'all are looking for some kind of guidance. And so keep in mind, this is what we're trying to mimic. Quit trying to solve stuff. Don't do number 3. Don't do part D. Does that help some of you guys get started with the vertex? Remember, the vertex is HK. If you want to type in your ordered pair for your vertex to me, if you want to send it to me privately, I will check it for you. Oh yeah, we're doing great. You guys are doing fabulously now. Okay. All right. So I'm gonna quit trying to answer chats and come back up here. All right. So my vertex, remember we take the x plus 1 to find h. To find the h. Take that x plus 1, set it equal to 0, and get x is equal to -1. We change that sign. Remember, this is a movement to the left because it's inside. It's that movement side to side, and so it's the opposite. So that vertex is -1, and then whatever number is out here is my k part. So literally whatever matches up here. So it's written as -2, but that means I added a -2, okay? The negative out in front has nothing to do with the vertex, absolutely nothing to do. However, it does have to do with whether it opens up or down, okay? So a is equal to -1, and that means that this is going to open. Annie, which way does it open?
Down.
Down. Thank you. Okay. So this one opens down. Okay. And then my axis of symmetry is the equation x equals -1. Once you get that vertex, the rest of it kind of falls into place. But okay. How are we doing? Several of you had little questions for me to begin with. Are those better? Are we better or worse? Because we're going to do something a little bit different in a minute. So we want to finish this problem with this standard form. Okay, so let's talk about those intercepts again. Remember, the intercepts are what happens when I take this and I set it equal to 0. So I'm going to have my function at negative, don't lose the negative, x plus 1 squared minus 2 is equal to 0. Okay, nice quadratic equation to solve. I'm adding 2 to both sides. That gives me negative x plus 1 squared is equal to positive 2. Now I have to get rid of this negative, and so that's going to be x plus 1 squared is equal to -2. What happens when I try to take the square root of both sides? Well, I get an imaginary number.
So does that mean that there are no x-intercepts?
Yes, yes, yes. Oh, you just made my day. That's exactly what that means. Okay. I'm sorry, I get so excited. I just love it. It's like the light bulbs are coming on, and that just incredibly I'm sorry, I didn't mean to get so excited there. Okay, so I have no real solutions here. And so that means I have no real zeros. And that means I have no x-intercepts. So that means this graph does not cross the x-axis. And you might be going, what the heck? How am I going to do this? Here's what I'm going to show you. Let's think about what this graph looks like. -1, -2. There's my vertex right here. You just got through telling me it opened down, right? It never crosses the x-axis. That is perfectly legitimate, okay? We do need to go ahead and find the y-intercept. And so we find the y-intercept by letting x be 0. So we have negative and then 0 plus 1 squared minus 2. And this is going to be negative. This is 1, so -1 minus 2. And that's going to be -3. And in terms of the point, this is the point 0, -3. Here is my y-intercept, okay? Remember the axis of symmetry? Well, that means that one unit to the left of this turning point is also going to have a y value of -3. That's just an extra bonus attraction. You don't have to have that, but it's just an extra bonus. And my graph looks like this, right? And indeed, it does not have any x-intercepts. So that was perfect. You think we planned that or something? That was amazing. All right, so domain is still negative infinity. The positive infinity, I kind of blow this one off because, I don't know, it's kind of boring. But range somehow is going to involve -2. Okay, somehow it's going to involve -2. Since this one opens down, then that means my range, remember my range is my y values. So it's going to go from negative infinity. Remember that vertex, it's at the top, it's a maximum, to -2. And that's my range. Questions? Looks like it. It's okay. It's excellent. All right. We good? Y'all are loving this or not? Anyway, like I said, it's a great review of what we talked about. So we've already talked about so many of these things. Okay. So this one is in a different form. Okay. This is in that general form. And so it's not quite so easy, but some people like it better because it's literally a formula for finding the vertex. So we use to find the vertex, h is going to be equal to negative b over 2a. You might recognize negative b over 2a. It's the first part of the quadratic formula, okay? If you take off all of that square root mess, it's negative b over 2a. There's a reason for that. You probably don't care what the reason, but there is a reason for that. But I'm just going to tell you that it's really not a brand new formula. It's just part of the quadratic formula, okay? So to find the vertex for this one, I need to identify a, B. I really don't care what C is, but we'll toss C in there just for the fun of it, okay? So I need to identify A and B. So the H part of my vertex, and that's the X part, okay? Remember the vertex is HK. It's in alphabetical order also, in case you didn't recognize that, is negative 6 over 2 times 3. And this is going to simplify to negative 1. Okay, I didn't tell you how to find the K part. So I'm going to ask you now, how do you think you would find the second part of the vertex? I'm open to suggestions. How do you think I would find the, and there is an ugly formula. It's gross, it's horrible, I don't even know what it is. So we're not going to use the formula. What do you think I would do to find the second part of this point that's called the vertex? Yes. Yes, I got an answer. Okay. I won't make you say it out loud. Okay. To find the y part of the vertex or the k part of the vertex, I'm going to plug in negative 1 for x in my function. So I have 3 times negative 1 squared plus 6 times negative 1 minus 4. And so this is going to be 3 minus 6 minus 4, and that's going to give me a nifty value of negative 7. And so that is the K part of my vertex. Okay? It's just a point on the graph, guys. It's nothing strange or mystical. Like I said, you can probably Google search and find a formula, but the formula made my head hurt the first time I saw it. And I was like, I am so not memorizing that. Okay. All right. So now the question is, we've identified A as being positive 3. And so since A is positive 3, then that means my function opens up. Okay. Positive people have smiles on their face. Negative people have frowns on their faces. Oh, I know, whatever. Okay. So A is positive 3, graph opens up. Axis of symmetry. Equation, x equals, we keep using that lovely negative 1. So x equals negative 1 is my equation of the axis of symmetry. Intercepts. And you're going, oh, yuck. Okay, that's okay. We've got this. Okay, so to find the x-intercepts, I'm going to come over here so I have lots of space. I'm going to use 3x squared plus 6x minus 4, and I'm going to set it equal to 0. Now, I might could factor that, but I don't know. So how do you solve every quadratic equation, including the ones that don't factor? I know you don't want to hear this, but it's okay. What will solve every quadratic equation? Yeah, it's that formula. I know, right? Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So let's just plug it in. So this will also give me my x-intercepts. So negative 6 plus or minus the square root of 36, that's b squared, minus 4 times 3 times negative 4, all over 2 times 3, which is 6. And so I have negative 6 plus or minus the square root of 36 plus 48. This is so not looking like a lovely number. It's okay. And that's going to be negative 6 plus or minus the square root of 84 over 6. Ooh, messy numbers, messy numbers. Okay. This is not going to be a nice integer. It's going to be hard to graph. So you are not actually going to use these intercepts to graph. We're going to be able to use our vertex and our y-intercept, all right? But it'll give you an idea. You will need to be able to list these. Probably not going to give you one of these on your test or quiz where you have to use the quadratic formula. Homework, you will see one where you have to use the quadratic formula, okay? So let's refresh how to simplify this radical. So this square root, I'm going to come over here to the side. So the square root of 84, this factors into 4 times 21. And 21 we can't do anything with. And so 4 is 2 times 2. And so the square root of 84 is 2 times the square root of 21. Okay, so just kind of finishing this out, I have negative 6 plus or minus the square root of 2 times the square root of 21 over 6. And this simplifies to negative 3 plus or minus the square root of 21 over 3. And those are my two x-intercepts. Ooh, icky, messy, yuck. So not going to graph those. But we still have an idea of where they are. One's going to be positive. Looks like one's going to be positive. One's going to be negative. We'll still be able to sketch the graph. Okay. I know that was really messy, but it's okay. It was a great review. To find the y-intercept, though, remember we need to find f of 0. That's such a nice number. 3 times 0 squared plus 6 times 0 minus 4. Everything disappears except negative 4. So my y-intercept is the point 0, negative 4. So let's graph that. And let's graph my vertex. Remember, it opens up, right? Okay. I have no idea where it comes down over here. So we're just going to make a pretend place. We don't even know exactly where it crosses because I don't care. It does have to turn around here and it goes up through there. And that is not a beautiful graph, but we get the idea. It does not have to be perfect. On MyLabs Plus, it will be perfect because one, it'll either be a multiple choice and you'll get to select their perfect graph, or you'll be able to just graph the vertex and the intercept and whoosh, it'll make a beautiful picture. I wish I could whoosh make a beautiful picture. All right, domain and range. Domain, still polynomial function, negative to positive infinity. Range involves negative 7. Is negative 7 the first value or the second value in my range? It is the first value. Excellent. So it's going to be negative 7 to positive infinity. Questions? I told you I get super excited about this part. I love this part. How are we doing? I think I really love this section because it just uses so much stuff that we've already done. It's like that, the building blocks, it puts it all together. It's like getting to the top of the pyramid. I know, very philosophical. Let's do another one. This one's going to have a really small y value. What you think on the graph? I know, kind of gives it away. Okay. This quadratic function doesn't have a c value, but it's okay. we can identify A and B, and that will allow us to find the vertex. Okay, so everybody find the H part of your vertex. And enter it into the private chat for me, please. Okay, some of you went a step further, but it's okay. Excellent. Answers. If you don't know, it's okay. You can say, I don't know. IPKs are amazing. That's okay. That's perfectly fine. I'm going to give some of y'all a jump start. So remember, H is negative B over 2A. A is in this formula, B is in this little formula. There you go. And it takes us a little longer to do this, but it makes me happy when I see people get answers. How are we doing? Okay, so remember it's negative B over 2A. So I have negative, but B is negative 8, remember? Right? So A is 1 that we can't see, and B is negative 8. So the opposite of negative 8 is going to be positive, and then 2 times 1. So I'm going to have positive 8 over 2, which is going to give me a positive 4. Okay. When I plug positive 4 in, I'm going to get a negative 16, right? So to find K, remember I do F of, in this case, 4. That's going to give me 16 minus 32, which gives me negative 16. And you probably kind of got an idea it's going to be negative because of this funky guy. Opens up or opens down? Yep. Oh, great. So one I didn't like it now. Okay, so make sure you're looking at the fact that I'm looking at the A, I'm not looking at anything else. So A is positive 1, and since it's positive 1, that means, and think about this. Don't think about the A part. Think about x squared, okay? Think about what x squared looks like. X squared is a parabola that opens up. What's going to make it open down? That would be a negative x squared, okay? So since it's a positive x squared, it has to open up, okay? I liked the all caps. I thought it was amazing. It made me excited. So, okay, so A is equal to 1 tells me that x squared is positive, and so it's going to open up. Be really, really careful there, okay? All right, axis of symmetry is x equals 4 in this case. Now let's talk about the x-intercepts. Okay, I want y'all to find the x-intercepts for me. There are 2 of them. 2 x-intercepts. I've done this. I'm tired of finding x-intercepts. Your turn. You can just list them. X equals this and this. You can just list the two numbers. You don't have to write them as an ordered pair. You don't even have to say x equals 2. And I'm going to give you a minute before I get you started. Yes. Come on. Too many responses, too many responses. That's excellent. Okay, so some of you are kind of stuck a little bit, so I'm going to give you a how-to to get you started. Ah. That's funny. All right. So several of you have gotten lots of good answers. I was waiting for a couple of more people. So on this one, you got to be really careful. I saw a couple of things that I tried to chat back to y'all, but we got a little bit, it got to be too many of y'all chatting and I got lost. So when I factor this x out of both pieces, and that's what you've got to do here, I'm going to get two equations to solve. I'm solving a quadratic. I get x is equal to 0 and x minus 8 is equal to 0. This first one gives me x is equal to 0, okay? And the second one, the x minus 8 equals to 0, gives me x is equal to 8. So my first ordered pair is 0, 0. This is the y value here. And remember when we found x to be 0, that's what happened. My second one is 8, 0. If you just listed the zeros, then it would be x is equal to 0 and x is equal to 8, okay? If you write them as ordered pairs, then you would write 0, 0 and 8, 0. Be really careful with using those parentheses for ordered pairs if you're not supposed to be writing an ordered pair. So just be careful there, okay? Your y-intercept, anybody know what the y-intercept is based on the fact we have x-intercepts? This one's kind of nice. We let 0 be equal to x, and I get 0. Yes. Yes, yes, yes. You're already figuring that out because I had 0, 0 as my y-intercept, my x-intercept. So 0, 0, 8, 0, and 4, negative 16, way down here, okay? And, okay, so it's kind of funky looking graph, but we got this. Okay, and so now I'm going to sketch my graph coming down. That's pretty close to a beautiful parabola. Yay. Okay. Finally, stating the domain and range. So the domain is negative infinity to positive infinity. And the range is negative 16 to positive infinity, square bracket, sorry. Be careful on that, so. Questions? Now I'm going to see if you really kind of got this. Y'all love this. Oh, you really got those questions. I know you did. All right. Without graphing the function, so see, you should be super excited. No graphing, no graphing, no graphing. The first thing we want to do is determine whether the function has a maximum or a minimum. The second part says find the maximum or minimum value and determine where it occurs. A little bit different question. And then finally, we're identifying the domain and the range. Okay. What do I look at to determine whether the function has a maximum or a minimum? Doesn't tell you in the directions. And so this is where I need you to think for me. What do I look at to determine whether this function has a maximum or a minimum? And you can either private, yep, that's that. I'm getting answers. That's great. Yep, yep, yep. Okay, let me get one more. Somebody else tell me what they think is going on. Yep, okay. So what I'm going to look at, y'all are great. Y'all are, yes, 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 yes. Excellent, excellent. Okay. I am looking at this thing right here, this coefficient of x squared, this sign in front of the x squared, the value of a, whatever you want to think of it. These directions are not going to tell you that. You have to determine whether it opens up or down. Y'all said all of these amazing, wonderful things, okay? So if a is -1, this means the function opens down, and if it opens down, then I am going to have a maximum. All right, plain and simple. If A is positive, it opens up and I'm going to have a minimum. If A is negative, it opens down and I'm going to have a maximum, okay? Think about turning down negative x squared. You should now know what negative x squared looks like. You're going to see this on your test. You're going to see this on your quiz. You're going to see this negative x squared. Which way does it open? So it opens down, it turns down, it has a maximum value. So then the next part says find the maximum or minimum value and where it occurs. So I don't need to find the minimum value because it's not going to have one. So we're not going to find the minimum. We're only going to find the maximum for this one. Okay. What do I need to find in order to find the maximum value? Doesn't tell me that. I need to find something else. What is it that I need to find the maximum value and where it occurs? Yep. Waiting for a couple more answers. Think about what I need to find to determine or to find the maximum or minimum. Yep. Yep, 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 yep. Okay, excellent. Okay, you have to find the vertex. So what these directions are telling me in secret code, I guess, is find the vertex or the turning point. And in this case, I'm going to find it by finding h and using -b/2a. And that's going to be the opposite of -4 over 2 times -1. 3 negatives are going to give me a negative, in this case 2. Now, here's where I need y'all to work for me. I need you all to find the k part of the vertex. And I need an answer from everybody who's still here. And if you don't answer me, I'm going to think you are not still here. So find me the vertex. And I'm not going to tell you if you're right or wrong. So just type it in and then I'll show you whether you're right or wrong. Okay. Find the vertex. I'm so proud of them. Only like one or two people is doing crazy things. So makes me happy. I'll give everybody a chance to answer this one because this one's like super important. It's so easy to mess this up. I love the not sures. It's okay. That's fine. We're good. We're good. IDKs are good. They're not good, but they're okay. They're fine. We can live with them. Carfaith, Clarence, y'all still there? Okay. So if you got 12, you are amazing, and I'm so super proud of you. If you didn't get 12, I'm still proud of you. Okay, I promise you're good. All right. So I need you to pay super close attention if you didn't get 12. Okay, you can pay attention otherwise, but I need you to pay super close attention if you didn't get 12. So to find the K part of my vertex, I'm going to put in -2. My function, you're good. No, you're good. You're good. My function is negative and then -2 squared minus 4 times -2 plus 8. Okay, so -4 plus 8 plus 8. And this is going to be 4 plus 8, which is going to give me 12. Okay, here's what I worry about students doing is forgetting and squaring this negative out here. This negative doesn't get squared. So y'all are amazing. Y'all probably had a better percentage rate of correct than most of my students do. So that's great. If you didn't, it's okay. Now you're not gonna miss it again. Now we have to answer the question though, because all we've done is find the vertex. One part of the vertex is the value, and the other one is where it occurs. And we talked about this the other day when we were looking at graphs. Can anybody tell me, based on looking at the vertex, what the maximum value is what? Which part of this is the maximum value? You got a 50-50 shot. So you could guess if you wanted to. I love the question Mark Shell said to me. You sure? Maybe. Are you questioning me or are you questioning you? There you go. Okay. Y'all are great. Okay. So the maximum value is 12 and it occurs at x is equal to -2. Yep, that's it. You got this. Okay. The value is the y part or the k part of the vertex, and where it occurs is the x part. It's okay. Right? So domain. Oh yeah, so we got the domain. We don't even have to have the graph because we know the domain is negative infinity to positive infinity. The range. Because it has a maximum value, that means my range goes from negative infinity to that maximum value. Okay? All right. You can sketch the graph. If it helps you to sketch the graph, sketch it. There's no graph police gonna run around and go, sketch the graph to figure this out. It doesn't matter. You need to sketch the graph, sketch the graph. Questions about this one?
I have a quick question.
Yes.
Is the value, the minimum or the maximum, will it always be the y part and then the where it occurs is the x?
Yes,
Okay.
that's perfectly said. That's exactly it, Cody. That's exactly it. Yep. Excellent. So the maximum or minimum value is always the y part, and where it occurs is always the x part. All right, one more question. That's it, just one more. Yeah, no, it's the same song, second verse. Okay. So let's decide. We got this now. I've walked you through it. You got this. Does this function have a maximum or a minimum? You can feel confident and shout it out. You can type it. Yep, yep, yep. Yep, 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 yep. No, I feel confident enough to shout it out to everybody. It's okay. All right. This function, and I'm going to walk through it because I got a couple of people who are not answering me. I'm looking at this value here. This is positive. That means it opens up, which means that it's going to have a minimum. Right? So that means that I'm not going to find the maximum value. I'm going to find the minimum value. And so that means I need to find the H part of my vertex, and I'm going to use the opposite of B over 2 times A. So I'm going to have a positive 8 over a positive 4, which is going to give me 2. Okay. Then I need to find the K part by plugging 2 in for X. And so I'm going to have 2 times 2 squared minus 8 times 2 minus 3. This is going to give me 8 minus 16 minus 3. That's looking like a negative 11. Okay? So that's my K part. So my vertex looks like this, 2, negative 11. Okay? So my minimum value is negative 11. And it occurs at x is equal to 2. What is my range? I'm not even going to ask you a domain. What is my range? Tell me what you think the range is. No, I told you I wasn't going to be able to get out of my parking lot. They put big orange cones up. I'm not going to be able to escape. Well, okay. I'm going to be here tomorrow. Yes, I'm sorry. Y'all are answering my question, and I'm stressing over here out of the fact I can't leave my parking lot. Yes, 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 yes. I think everybody who's gotten it right so far. Excellent. Very good. Okay. Make sure I've seen a couple of people who didn't put the brackets on here. So be careful. Make sure you have that square bracket. It does start at negative 11 and it goes to positive infinity. You guys are amazing. This is why I love this section, because we put so many things together, ranges and domains and maximums and minimums, and you're going to see all of that stuff. Where does the graph move? How does it translate? All of that stuff's going to be on this test. So you guys are great. Yahoo! All right, here ends section 4.1. This is all we do in chapter 4. It's got so much fabulous stuff. So, okay. So, do you have any questions that you didn't send me, because nobody sent me questions, about what's going to be on the test tomorrow? Or did I just do you this amazing review right now? Or questions on anything else we've done?
I have a question about one from the mastery quiz.
Yep. What you got?
The problem was x minus 8y equals 8 with points +2, +3. And it wanted the answer in slope-intercept form.
Okay, was it parallel or perpendicular to this line?
I think it was perpendicular, but I don't remember.
Okay, well, we'll work it based on perpendicular, okay? So write the equation. Perpendicular. This is actually a fabulous question. To this equation and through this point. And we want the final answer in slope-intercept form. Okay, so before you can do anything else, you've got to find the slope for this line. And so the slope for this line, so we need to find m for this line. So we're going to solve this for y. So we're going to start with negative 8y is equal to negative x plus 8. So we subtract x from both sides. Divide everything by negative 8. That's going to give me positive x over 8 minus, and when we divide this, we're going to get 1. So the slope for this line is 1/8. However, to write the equation perpendicular, so if we want to write the perpendicular line, and so perpendicular to m is equal to 1/8, we need to change the slope to be negative 8, okay? So if it's perpendicular to this one, the positive 1/8, we need to flip it, make it 8, and change the sign to a negative. And so then we can use the slope of negative 8 and the point of 2, 3. Start off in point slope form, so y minus 3 is equal to negative 8 times x minus 2, right? And y minus 3 is equal to negative 8x plus 16. Adding 3 to both sides, I get y is equal to negative 8x plus 19. And here we have our slope-intercept form for our final answer. Does that make sense?
Yes, ma'am.
Perfect. If it had said parallel to it, we would have just used the 1/8 and the point and gone through the same process. Excellent. Other questions? Okay, guys, I will be checking my email. I've got a couple of meetings this afternoon, so I'll be in and out checking my email, but I will check my email. So if you find yourself studying and have questions, feel free to email me. I will get back to you as soon as I can. Test is tomorrow morning. Make sure you remember to come and join us and check in and all of that good stuff. And I will see you tomorrow. So, bye.
Can you go back to the first slide?
To the very first one? Yes, like the very first one,
No, I just need to take.
where all that stuff was, yes. This guy right here.
I do have a quick question about tomorrow's test.
Yes.
You probably already said this. I just don't remember what you said. What is the chapters? Because the syllabus says the 4-1.
Say, hang on. What now?
Like, what chapters are the tests on tomorrow? 'Cause the syllabus says 4-1, but I don't remember if you said.
No, 4-1
Today.
is not on it.
Okay.
4-1 is not on it. So I did take that off.
Okay, thank you.
Uh-huh. Justin, do you need me to move this up or down? You can still hear Justin. Alasia, you still there? Clarence, I don't think you're still there either.